All right, so today's lesson is going to cover this P.1 section, Intro to Integers. The idea behind this P chapter is sort of to make sure we're all up to speed with some of the skills that you've learned from maybe middle school or elementary school. In Algebra 1, it's important that you're able to do these computations correctly and accurately because we're going to build on those skills in the remainder of this course. So this is review for a lot of you, but just to make sure we're on the same page, I'm going to cover it piece by piece. So this section, this P.1 section, is going to be Intro to Integers. All right, so starting with the definition of integers, integers are all of the positive and negative whole numbers. Whole numbers, right? That's your key here, right? There's no fractions or decimals that are integers. So for example, we can start at 0 right here, and then everything greater than 0, so every positive number is going to be to the right of 0 on a number line. All right, so 1, 2, 3 you see listed here, and so on and so on and so on. Every whole number after that is an integer. The same in the negative direction, right? So we can even say -1, -2, -3, and so on and so on and so on. Those are all integers, including 0, right? 0 itself, it's not positive or negative, it's just 0, but it is an integer and we count it with our integers. So now graphing these integers on a number line, the first step is to draw a number line if it's not given to you. Right? Chances are if you're doing it with me, I'll give you a number line, and whether it's labeled or unlabeled, you should at least be able to locate where it is. And then the second step is to just draw a dot at the point that represents the integer. So here they have it labeled, so you can see there's a number under each little tick mark on the number line. All right, we have -7, -6, -5, and so on and so on and so on. So for example, -6, this number right here, I'm just going to find -6 on the number line, and I'm going to draw a dot right there, just right over it. Now, if you didn't have a labeled number line, you can always start at 0, right? At least label a point 0. That's always a safe place to start. And if it's a negative integer, you're going to go to the left, right? So negative is to the left. So this direction is going to be your negatives, right, to the left of 0. And then if your integer is positive, you're going to go to the right. Okay, so this to the right of 0 is going to be your positive direction for integers. But here they give it to us labeled. So I'm just going to go ahead and find, okay, so now my next integer is -2. I'm going to find -2 on my number line, and I'm going to just draw a dot right over it. Right? And again, if it wasn't labeled, you would at least find a point 0 just to establish where you're going to start. And then if it's negative, you're going to go to the right, to the left 2 units, right? 1, 2, and then you end up at -2. Same thing with +3, right? 3, there's no sign in front of it, so it's positive. And positive goes to the right of 0, right? So from 0, starting at here, I'm going to go right 3 units, 1, 2, 3, and then you end up at 3. Or similarly, this one is labeled for you, so you can just find 3 on the number line and graph it there. All right, and here's some more examples with just graphing from on a number line. All right, so example 1, starting at -7. You just have to find -7 on this number line. It's right here. Or if it wasn't labeled, you can start at 0. Again, 0 is always a safe place to start. And then since it's negative, you're going to go to the left 7 units. 1, 2, 3, 4, 5, 6, 7. All right, and then you end up at -7. 0 is just 0, right? We don't move any place from 0, so I'm just going to draw a dot over 0. And then +5, right? There's no sign in front of the 5, so it's positive. So starting at 0, I'm going to go to the right 5 units. 1, 2, 3, 4, 5. And then I'll let you guys try the second example on your own. So just give it a try and then keep watching. Another important skill with integers is being able to recognize which integer is bigger or smaller compared to other integers. So this example is asking us to order the integers -4, 0, 5, -2, 3, and -3 from least to greatest. Now, if you were to just graph them on a number line, you can always go one by one and read it from left to right. So starting at -4, that point's going to go over here. Right? You see it written here already, but I'm just going to go through the process. So the next integer is 0. Draw a dot right over 0. Next one is +5. It's positive, so it's going to be to the right of 0. Right? You got a dot right there. All right, next one is -2. Draw a dot right over your -2. We get a +3. Right? Label that on the number line. And then finishing with the -3. All right there. And then the order is just going to be the order that you see them from left to right. Right? From left to right is from least to greatest. Right? And the order that they appear is -4, -3, -2, 0, 3, and 5. So here's some more examples of that. Like before, I'm going to do the first one, and then I'll let you try the second one on your own. So number 1 says order the integers 4, -2, -5, 0, 2, and -1 from least to greatest. All right, well, I'll start with -4. I'm sorry, I mean +4. It's just a +4. So I'm going to find 4 on the number line and draw a dot right over it, representing that 4. My next integer is going to be a -2. I'm going to find where it says -2 and draw a dot right over it. Next one is -5. Again, draw a dot right over it. Right, and then I have 0. 0 is just 0. I just leave it alone. And then I have a +2. And then a -1. And then my order from least to greatest is just the order that I see them from left to right. So my order is going to be -5, -2, -1, 0, 2, and 4. All right, that's my order from least to greatest. Now you can try the next one on your own. So now we get into a concept called absolute value. The absolute value of a number is the distance to 0. So you can think of it like directions, right? If I'm 5 miles east of Archbishop McCarthy, so let's just say this, right? Let's say this 0 right here. This is Archbishop McCarthy. I'm 5 miles to the east. Let's say someone else lives about 5 miles to the west, right? I wouldn't say I'm -5 miles, right? I would just say I'm 5 miles from the school, right? So this is a similar concept, right? So one direction, east, you could say maybe that's positive, and then you can say maybe west is negative, but either way, you're still going to be a certain miles away from the school. So that's kind of the concept of an absolute value. Again, you've probably seen this before, but we're going to get into some more problems on how to apply it. All right, so our example here, like I said, is going to be 5. Absolute value of 5 is just 5, right? Because 5 is 5 units from 0. And then -5, the absolute value of -5 is +5, right? Because you're 5 units from 0. And then the absolute value of 0 is always 0. And then here's a couple examples. When you're evaluating the absolute value, you want to know how far the number is from 0, right? So -4, if I were to draw a point on -4, and you ask how many units is this -4 from 0, I would just have to count 1, 2, 3, 4, and I end up with 4 units from 0. Or you can just recognize that I have a negative number inside of my absolute value. It's always going to give you a positive number. If the negative is on the inside, you always get a positive number on the outside. Right? So similarly with the absolute value of 3, right? So I'm going to draw a dot over the 3, and it's 3 units from 0. 1, 2, 3. 3 units, and then I end up at 0. But the absolute value of a positive number is always a positive number. So it just stays 3. Similarly with -9, right, you could draw it and count how many units, or you can just recognize that the absolute value of a negative number is always going to give you a positive number, right? So the absolute value of negative 9 is positive 9. All right. And then example 4, looks like there's a typo here. Let me get rid of this plus sign right here. Let's just evaluate the absolute value of 8 minus 3. Right? We can treat the absolute value like a parentheses. So we're just going to leave 8 minus 3 on the inside. That's going to give you 5. So I'm going to write the absolute value of 5. And then the absolute value of 5, again, absolute value of a positive number, just gets you a positive number. So then the absolute value of 5 is 5. All right, and now opposite numbers are just numbers that have the same absolute value, but they have different signs. So for example, negative 6 and 6 are opposites because they're both 6 units from 0, but they have different signs. So you see 1, 6, this one right here, this gives you a negative 6. Its absolute value is 6. It's 6 units from 0. 1, 2, 3, 4, 5, 6. And then same thing with positive 6. Positive 6 is 6 units from 0. 1, 2, 3, 4, 5, 6. Right? Either way, we end up with 6 units, and they're both positive 6 that when you take the absolute value. Right? So we call these numbers opposites. And now applying this to some real-world scenarios, right? Let's look at this first example. The graph shows the position of a diver relative to sea level. Use absolute value to find the diver's distance from the surface. Right, so here we can just look at the image, right? Sea level is going to be our 0, right? So our 0 portion of our number line, right? And then if this diver, it looks like he's about negative 18, right? We have a little dot over that unit. So it looks like this diver is 18 feet below sea level, right? But his distance to the surface, I would just take the absolute value of negative 18. And the absolute value of negative 18 just gets you positive 18. All right, same thing with this whale, right? So this graph shows the depth of a whale in feet. Use absolute value to find the distance the whale must travel to reach the surface. All right, well, again, sea level is going to be our 0 point. And then this whale, it looks like it's about negative 250 feet below sea level, right? Just the distance between negative 200 and negative 300. So I'm going to say that his distance, this whale's distance to the surface, is the absolute value of 250. And then the absolute value of 250 just gets you 250. And now it's important to be able to recognize which integer is bigger, right, when comparing two integers, right? So looking at negative 4 and positive 1, all right, graphing each of these points on a number line, negative 4 is right over here, and then I'm going to graph negative 1 over here. And we always say that the numbers increase going from left to right. So negative 4 is on your left. That's going to make negative 4 less than 1, since 1 is the number on the right. So we say negative 4 is less than 1. And then that's our comparison. Let's say now let's try comparing negative 2 and 2. All right. I'm going to graph each of these points on the number line. So if I have negative 2 right here, and then a positive 2 right here, right? Which number is to the left and which one's to the right, right? Our negative 2 is the number to the left. So I'm going to say negative 2 is less than positive 2. And then lastly, let's just compare some absolute values, right? So for each of these 4 examples, we're going to evaluate the absolute value of these numbers and determine in which order they go in, right? So negative 4, the absolute value, right? Absolute value of any negative number is a positive number, right? So this is going to be 4, and then the same with absolute value of negative 3 is going to give you a positive 3. Right? So 4 is greater than 3. Right? Greater than is going to go in here. All right, and now for absolute value of 12, right, it stays a positive if there's a positive in the absolute value. So I'm going to write 12 equals 12, or absolute value of 12. And negative 12, the absolute value of negative 12, if I have a negative in my absolute value, it goes away. So this equals positive 12. Since they're equal, the sign in the middle should be an equal sign. All right, and now for negative 20, absolute value of negative 20, again, the negative goes away if you're doing an absolute value of a negative. So then we get absolute value of negative 20 is positive 20. And then the absolute value of 10 is just 10, all right, it stays the same. So then we get that 20 is greater than 10. And now absolute value of negative 16, all right, again, if there's a negative in the absolute value, it goes away. So we get 16 is the absolute value of negative 16. And then the absolute value of 18 stays 18. So then 16 is less than 18. All right. Now, the classwork that we did reflects all of these topics that we covered. Pretty basic introduction to integers, and then we'll spend maybe about another week on computing integers. Again, this might be review for some of you, but just to make sure we're all on the same page, because these are important skills that we're going to need for the remainder of the course. All right.